Hello and welcome to yet one video about differential equations. In this one, we are going to introduce homogeneous differential equations and we are going to solve how, using a substitution, we can convert this family of differential equations into separable ones and hence we can solve them. So we call a differential equation homogeneous if it has the following form. We are going to have the derivative of y with respect to x to be equal to a function of the ratio between y of x and x. We are not going to discuss why these equations are called homogeneous. We just want to know that they are of this form and that the substitution that we need to use is the following. We are going to say that y of x is the same as a new function v of x multiplied by x. This is our substitution. And this implies that if we take derivative with respect to x on both sides, we are going to say that the derivative of y with respect to x is the same as, and now we have to apply the chain rule on the right hand side. We have to take the derivative of v with respect to x times x plus v of x times the derivative of x with respect to x, so times 1. So this means that our substitution is going to change also the left-hand side of our differential equation. So our new differential equation is going to be of the form the derivative of v with respect to x times x plus this new function v of x. So now we are going to have a differential equation on v is equal to the function, and we want to write what is y over x, but from the substitution we have that y over x is the new function v, so the function evaluated at v is our right hand side. Let me go one step more. I'm going to say that the derivative of v with respect to x times x has to be the same as the function at v minus v. And if x is different from 0, then we can divide by x, and we are going to have that our differential equation looks like the derivative of v with respect to x is the same as the function f evaluated at v minus v, all of this times 1 over x. And this is a separable differential equation that we can solve. So over here there will be some work to solve the differential equation. Let me write here that it's separable. And then after we solve it, we are going to find what is the function v. But we don't want to know what is the function v. We are going to need to find what is the function y by multiplying by x the function v of x that we found solving the separable differential equation. Let's see an example of this method. We want to solve the initial value problem that has dy dx is equal to x plus 2y over x and the condition that y at 3 takes the value 3 over 2. First of all, we need to check that this is really a homogeneous differential equation, and we can see that we can actually rewrite the right hand side as 1 plus 2 times y over x. So we could say here that our function of y over x is 1 plus 2 times y over x. So this looks like the homogeneous differential equation that we defined in the above. We now want to do the substitution that y of x is going to be x times v of x. And you may remember by heart what that implies about the derivative of y with respect to x. I never bothered to do that. I just going to take derivatives on both sides of the equality. So I'm going to say that the derivative of y with respect to x is the same as, and here is where I apply the chain rule, the derivative of v with respect to x times x plus v of x, because the derivative of x with respect to x is 1. So now I'm going to rewrite my differential equation, this time in terms of v instead of y. So I have dy dx times x plus v is equal to 1 plus 2 times, and then I have y over x, but that's v. So if I isolate here for x different from 0, if I isolate the dv dx on the left hand side, then we have dv dx is equal to, and we have 1 plus 2v minus v, so 1 plus v divided by x, and this is a separable differential equation. And actually, we want to write everything in terms of v on the left-hand side, so I'm going to rewrite this as 1 over 1 plus v. Here I have one more condition. I need to make sure that v is not negative 1, times the derivative of v with respect to x has to be the same as 1 over x. And this is the separable differential equation that we want to solve. Now I suggest that you stop the video and try to solve this differential equation, and then you see if you got the same as I do. And here you can see my result. I'm getting that the function y we were trying to find is equal to a half x squared minus x.